Hi, welcome back to my channel. And last day we have discussed few problems based upon the formulas which we have learned. We have learned many formulas like area of triangle is equal to L into B, area of triangle is equal to half into BH, area of rectangle is equal to length into breadth, area of parallelogram is equal to base into height, and area of trapezium is equal to half into h into a plus b, where a and b are length of the parallel sides. Then area of a general quadrilateral is equal to half into d1 d into h1 plus h2. So all those formulas we have learned, and today we are going to continue the discussion. But today we are going to continue the discussion of solids. Actually the chapter we started with by discussing solids. Then after 2 days we went to other topics like shapes. So we have to continue the discussion of solids again. So which were the solids we have discussed? Cube, cuboid and cylinder. Repeat, cube, cuboid and cylinder. These are the three solids we have discussed, and these are the three solids in your chapter. Okay, 9th standard we are going to learn about few more solids, but in 8th standard we will learn only cube, cuboid and cube, cuboid and cylinder. So let me start the discussion of cube. Okay, listen. So this is picture of cube. So you can write side heading cube. Three formula you have to learn in the case of cube. Since this is a cube, all sides are equal, no? So let it be some A units. All the sides are equal. Let it be A unit. Total surface area formula is 6A square. Lateral surface area formula is 4A square. And the volume formula is A cube. Three formulas. Total surface area is equal to 6A square. Lateral surface area is equal to 4A square. Volume is equal to A cube. These are the three formulas which we have to learn under cube. Is it clear? Okay. First question is total surface area. Total surface area is equal to 6A square. It means 6 into A square. 6 into A square. We will solve more problems based upon this formula later. Now today we are going to learn formulas only. Total surface, we have learned the formulas of shapes. Today we are going to learn formulas of solids. Okay, both are different. Total surface area is 6A square. What do you mean by total surface area? The area of all surface. How many surfaces are there? Front face, back face, then 2, then side face 2. Front face, back face, so 2. Then this side face and that side face, again 2 plus 2 4. Then up face and down face 6. Total 6 surface is there in a cube. So total surface area is 6A square. The formula is 6A square. A stands for side of square, side of the cube. One side of the cube is nothing but A. Total surface area is equal to 6A square. This is the formula for calculating total surface area, and so total surface area means the sum of area of all surface. What the meaning of total surface area? Total surface area, the short form is TSA. So you can write like this: total surface area is equal to TSA is equal to 6A square. Total surface area formula is 6A square. In bracket we can mention the meaning of total surface area. What is the meaning of total surface area? Sum of areas of all surface. Sum of areas of all surface. That is what is total surface area. എല്ലാ സർഫസുകളുടെയും ഏരിയയുടെ തുക, ഏരിയയുടെ സം, അതിനാണ് 6A square total surface area. Then let me come to lateral surface area. What do you mean by lateral surface area? Sum of areas of side faces. It means how many side faces are there? This is one side face, then back. In a cube altogether 6 faces are there. 6 faces, and in that 6 faces 4 faces are side faces. That means ഇത് മുകളിലും താഴെയുള്ള ഫേസിനെ നമ്മൾ സൈഡ് ഫേസ് എന്ന് പറയില്ല. സൈഡിലുള്ള ഫേസസിനെയാണ് സൈഡ് ഫേസ് എന്ന് പറയുക. അതായത് മുൻഭാഗം, പുറകുഭാഗം, പിന്നെ ഈ സൈഡ്, പിന്നെ ഇപ്പുറത്തെ സൈഡ്, അങ്ങനെ സൈഡ് ചുറ്റുമുള്ള ഫേസസ് എത്ര എണ്ണം ഉണ്ടത്? 1 2 പിന്നെ പുറകിൽ 3 പിന്നെ ഈ സൈഡ് 4. മുകൾ ഭാഗവും താഴ്ഭാഗവും ഉൾപ്പെടില്ല. അതിനെയാണ് ലാറ്ററൽ സർഫസ് ഏരിയ എന്ന് പറയുന്നത്. അപ്പം ചുറ്റുമുള്ള ഫേസസിനെയാണ് നമ്മൾ ലാറ്ററൽ സർഫസ് ഏരിയ എന്ന് പറയുന്നത്. അത് 4 എണ്ണേ ഉള്ളൂ. സോ ലാറ്ററൽ സർഫസ് ഏരിയ is 4a². So where we can use the concept of total surface area? Suppose the things related with the surface, there we will use the concept of surface area. Repeating, the problems related with the surface, we will use the concept of total surface area and lateral surface area. It means that suppose if we are going to paint a cube, painting can be done on the surface, no? So it is related with the surface area. Okay, when you paint a cube completely on 6 faces, there we will use total surface area formula. Why? Because someone is going to paint the entire cube, all faces, total surface, there we will use total surface area concept. And someone is going to paint only the side faces, there we will use lateral surface area concept. Anyway, the problems related with the surface are there we will use the concept of total surface area and lateral surface area. So according to the question, if all surface must consider, then there we will use total surface area. If only side faces are considering, there we will use lateral surface area. And the next formula is for volume. Volume is equal to a raised to 3, a cube. So a cube means, what is mean by a cube? A into a. What is this a? A is one side of the cube. So this is the formula for calculating volume of cube, a cube. So where we can use volume concept? Suppose someone is going to fill some water in a cube. If someone is going to fill some sand in a cube, if how much air is occupied in a cube, in all these cases we will use the concept of volume. That means volume can be used the situations like filling water or filling sand, or how much air is. So as I mentioned, the situations we can use total surface area is, suppose someone is going to paint all the surface of a cube or any solid, there we will use total surface area. And where we can use the concept of lateral surface area, if someone is going to paint only side faces except the up face and down face, then we will use lateral surface area concept. This is not only the matter of painting, anything related to surface, there we will use surface area concept. And where we can use volume concept, how much air is inside, how much water we can fill in this cube, or how much sand we can fill, there we will use the concept of volume. That means something based in related to the interior capacity, there we will use volume concept. Is it clear? And this is the formula. And let me go to the cuboid now. This is the general shape of cuboid. Okay, you know, this portion that is known as the length of the cuboid, this portion or this portion, see, this portion or this portion, that is what is the length. This portion is known as breadth, and this portion is known as height. This is the formula, this is the dimensions of a cuboid: length, breadth and height. In the cuboid also we have to learn total surface area, and we have to learn lateral surface area, and we have to learn volume. Here in the case of cuboid, the formulas are little bit lengthy. The lateral surface area formula is 2 into LB plus BH plus LH. This is the formula. 2 into a bracket, inside the bracket LB plus BH plus LH. This is the formula for calculating total surface area. 2 into inside bracket LB means L into B, length and breadth, plus B into height, breadth and height, plus length into height, L into H. Okay, so 2 into this quantities, it will give you total surface area. So where we can use the concept of total surface area? So total surface area formula is different for cube and cuboid. You have to distinguish it and you have to learn. You know, I have started calling students to school, and I started giving punishments, painful punishments to the students, those who are failed to give the answer. So be serious. So total surface area, this is the formula. Clear? Total surface area formula is 2 into LB plus BH plus LH. This is the formula. and lateral surface area. Okay, where we can use the concept of total surface area. While someone is going to paint a cuboid throughout all the surface, there we can use the concept of total surface area. So in total surface area, all the surface we have to consider: front face, back face, side face, and up face and down face, everything. In the case of lateral surface area, the formula is 2 into LH plus BH. This is the formula for calculating lateral surface area: 2 into LH plus BH. 2 into LH plus BH. This is the formula for calculating lateral surface area. So in the case of lateral surface area, only side faces we will consider. That means front face, back face, and this side and this side. Both upper face and lower face will not include in the case of lateral surface area. In the case of lateral surface area, only the side faces must consider. This is the formula: 2 into LH plus BH. So 2 inside a bracket L into H plus B into H. And you may understand what is this LBH and everything. And this is the formula for total surface area. This is the formula for lateral surface area, where we can use lateral surface area if suppose someone is going to paint only the side faces of a cuboid. There we can use this formula. Okay. Then volume. Volume, the formula is very simple: L into B into H. L into B into H. L into B into H. This is the formula for calculating volume of a cuboid. That means suppose someone is going to fill some water in a cuboidal flask, or someone is going to fill in some water in a cuboid, some sand in a cuboid. If someone is going to calculate the amount of air inside a cuboid, all those cases we will use the concept of volume, and this is the formula. Moving to the last solid, cylinder. So we are going to learn about cylinder now. Okay, and your friend will explain. He will define what is cylinder. Okay, Stevenson, can you define what is cylinder?
The object object have two sides. Is circle.
Two faces.
Two faces. Is circle.
Two faces in the sense upper face and
lower face.
That should be circle, no?
Circle.
Okay. Can you give an example?
PVC pipe and water bottle.
Water bottle. Okay. Can you bring your water bottle? Yeah. Yes. So the water bottle, as he said, he given us a correct definition of cylinder. That means it is a solid with both ends are circle, and he given me an example as PVC pipe. PVC pipe is a good example. And next he given an example as water bottle. Water bottle is almost like a cylinder, but the problem is you just see the lower base. That is a circle. Can you take this cylinder? See, you just see the water bottle lower base. That is exactly a circle, and upper base also a circle. But the problem is lower circle is bigger than upper circle. That will not be possible. In a cylinder, the lower circle and the upper circle should be in same size. In PVC pipe, both are in same size. But here lower circle is bigger than upper circle. So we cannot consider this as a perfect example for cylinder. Somehow it is cylinder. Understood? Cylinder? So what should be the specialty of a cylinder?
If lower side and upper side need to be circle, and it's open or closed to be.
My question is, Stevenson, is it a cylinder? Perfect example.
No.
What is the problem here?
Because it's lower face, it has more correct circle, but the
upper base is a smaller circle when we compare with the lower. So both circles should be in same size, no?
Yeah.
Okay, you can go. So we understood what is cylinder, and you may understand the specialty of cylinder. I am not going to explain once again. As Stevenson said, both ends should be circle, and since both ends are circle, in circle there should be radius, no? What is the specialty of circle? There should be radius. So we can mark that radius as R. In cylinder, there will not be L, B and A and everything, because in cylinder the shape, the lower face and upper base are circle. So that there we can use the dimension as radius, usually denoted by R. R is the radius, half. In a circle, if this is radius, when you complete that one, we will get the total length as diameter, and half of the diameter is what is radius. And of course this is radius, and this length we can mark it as height of the cylinder. So this is the height of the cylinder and this is the radius of the cylinder. I repeat, this is the height of the cylinder and this is the radius of the cylinder. Clear? Okay. And in the case of cylinder also there exists lateral surface area or caved surface area. So you have a doubt, sir, for cube and cuboid we have mentioned lateral surface area. Why it becomes caved surface area? You may think that in the case of cube and cuboid we have mentioned lateral surface area, but in the case of cuboid also we have mentioned lateral surface area, but when we come to the cylinder we can mention it as lateral surface area or caved surface area. How this caved surface area came? You may have that kind of a doubt. Okay, so I will explain that. So in a cylinder, lateral surface area or caved surface area both are same, and then of course total surface area will be there, then volume. Okay, as in the case of cube and cuboid. So let me tell you why this lateral surface area of a cylinder is also known as caved surface area. Let me tell you one thing, lateral surface area of a cube or lateral surface area of a cuboid will not be known as caved surface area, but in the case of cylinder, lateral surface area is known as caved surface area also. Why? Because cylinder's caved lateral surface is almost caved. ഇപ്പോൾ നിങ്ങൾ നേരത്തെ സ്റ്റീൻസൺ കൊണ്ടുവന്ന വാട്ടർ ബോട്ടിൽ നിങ്ങൾക്ക് മനസ്സിലായി അതിൻ്റെ ലാറ്ററൽ സർഫസ് എന്ന് വെച്ചാൽ ചുറ്റുമുള്ള, ഇതിപ്പോൾ നിങ്ങൾ ഈ മാർക്കർ നോക്കുക, ഈ മാർക്കർ ഒരു സിലിണ്ടറിൻ്റെ ആകൃതിയിലാണ് ഏകദേശം ഉള്ളത്. ഈ സിലിണ്ടറിൻ്റെ ലാറ്ററൽ സർഫസ് ഏരിയ എന്ന് വെച്ചാൽ ഈ സിലിണ്ടറിൻ്റെ ചുറ്റുമുള്ള ഏരിയ, അതായത് ചുറ്റും മുകൾ ഭാഗവും താഴെ ഭാഗവും പെടില്ല, ചുറ്റും ആ ചുറ്റുമുള്ളത്. ഒരു PVC പൈപ്പ് എടുക്കുക, ആ PVC പൈപ്പിൻ്റെ മുകൾ ഭാഗവും സർക്കിൾ താഴെ ഭാഗവും സർക്കിൾ, അത് ലാറ്ററൽ സർഫസ് ഏരിയയിൽ പെടില്ല. ചുറ്റും മാത്രമുള്ളത് ഇങ്ങനെ വളഞ്ഞിട്ടുള്ളത്. അതുകൊണ്ടാണ് ആ ചുറ്റുമുള്ള ഏരിയനെ ലാറ്ററൽ സർഫസ് ഏരിയ ഓർ കേവ്ഡ് സർഫസ് ഏരിയ എന്ന് പറയുന്നത്. കേവ്ഡ്. Okay, because that is caved, no, that's why. And the formula is given by 2 pi r h, 2 into pi into r into h, where pi you can use the value 3.14 or pi you can substitute the value 22/7 as our convenience. 2 into pi into r into h, 2 into pi, both values are given, any one value you can choose. Then r is nothing but radius and h is nothing but height. Okay, that is what is caved surface area, lateral surface area, where we can use this concept. Suppose if someone is going to paint the caved surface of a PVC pipe, there we can use the concept of caved surface area. And total surface area formula is 2 pi r into h plus r, 2 pi r into h plus r, 2 pi r into h plus r, 2 pi r then into inside bracket h plus r. This is the formula for calculating total surface area. Here pi is both value we can use, any one value you can use, 3.14 or 22/7. And this is the value, this is the formula for calculating total surface area of a cylinder, 2 pi r into h plus r. And how this formula came, what is the derivation of these formulas, how this formula came, why we are using this kind of a formula here, so all those things we will discuss in 9th standard. Okay, so total surface area is 2 pi r into h plus r. Clear? So where we can use the concept of total surface area, where what do you mean by total surface area? Total surface area means side area plus upper circle area and lower circle area. That means in the case of total surface area we will consider the side area and upper face and lower face, everything. Okay, that means caved surface area also we will consider, and upper circle and lower circle. That means in the case of this cylinder, total surface area stands for the side area or caved area plus upper circles area plus lower circles area. Every face we will consider in the case of total surface area. And formula is given by 2 pi r into h plus r. And the volume formula is very interesting formula, pi r square h, pi into r square into h. Pi into r square into h is the formula for calculating volume of cylinder. Pi into r square into h, where we can use the concept of volume. If someone is going to fill water in a cylindrical flask, someone is going to fill some sand in a cylindrical flask, or how much air is inside in a cylindrical flask, where for in those kind of situations we will use the concept of volume. Pi r square h is the formula, pi into r square into h. Okay, so we have learned 3 sets of formula today. Please by heart formula, and next day we will solve some problems. I think by next 2 videos we will conclude our revision. Clear? That means we will conclude this chapter by next 2 videos. Okay. So thanks for watching the video, and let me discuss about the revision plan. And because this chapter is going to complete, with this you are supposed to start your revision work also. And let me present the revision plan. And these are the chapters which are, that means we have to revise for our annual exam, no? Yes. So this is the revision plan, and these are the chapters I included for the first part of revision. Rational numbers, then second chapter linear equation in one variable, then third chapter understanding quadrilateral, and fourth chapter is practical geometry. These 4 chapters you should revise within 3 days. These are the 3 days you can use for these 4 chapters: 23 February, 24 February and 25 February. Within these 3 days you are supposed to finish the revision work of these 4 chapters. Please start the revision work seriously and complete the revision work of these 4 chapters within these 3 days. If you have any doubt on these 4 chapters, you can call me and ask me a doubt. But on the day of 25th February, I will conduct live class and I will conduct live test, and I will check whether you will have learned all these 4 chapters. I will conduct live. The live test can be maybe individual to individual. That means student. I will choose some students, or I will call students separately through WhatsApp calls, and I will ask you questions separately. Okay, it can be in any way, so prepare for that. On 25th February I will call you. You can expect my call at any time, and I will ask you question about this chapter: rational numbers, linear equation, one variable, understanding quadrilateral and practical geometry. And one more plan is there. On 25th, സോറി, നിങ്ങൾ 23rd സ്റ്റാർട്ട് ചെയ്യാൻ പറ്റില്ല, കാരണം നിങ്ങൾക്ക് ഈ വീഡിയോ കിട്ടുന്നത് 24th അപ്പോൾ 24th, 25th, 26th ഈ 3 ദിവസങ്ങളായിട്ട് നിങ്ങൾ സെറ്റ് ചെയ്യുക. ഏതൊക്കെ ദിവസങ്ങളാണ്? 24, 23ക്ക് സ്റ്റാർട്ട് ചെയ്യാൻ പറ്റില്ല. 24, 25, 26th February ഈ 3 ദിവസങ്ങളായിട്ട് നിങ്ങൾ റിവിഷൻ സെറ്റ് ചെയ്യുക. ഞാൻ എന്ത് ചെയ്യുന്നത് വെച്ചാൽ 26th February ഈസ് ഫ്രൈഡേ ആണോ? So 26th February, Friday, I will call you separately through WhatsApp calls, and I will ask you question based upon this 4 chapter. And one more plan is there. On 26th February, I will select 6 students from 8th standard, and I will make them to come here in school. That 6 students may not be Steenson or Adish or Arindajan or all the students, because they are coming here daily. That 6 students can be different from those students, and I will make them come school and I will ask you questions. It's my way. So on 26th February, I will choose 6 students, and I will make sure whether they have whether at least that 6 students have completed this 4 chapters revision or not. And remaining all students, I will call through WhatsApp. So expect my call and complete your revision work. Okay. And in addition to that, you are supposed to watch this video properly, and you have to learn all the formulas. I will ask you the formula also. Thank you. Stay safe. Bye.